I will start recording.
Yeah.
Start, sir.
Yeah, please.
Okay, okay.
Good evening to all the participants. I welcome the AROHAN 2024 the lecture series 4. Today we have a distinguished speaker. So before introducing speaker, I would like to just welcome our honorable Principal Secretary and Commissioner Sir and Director for this lecture series. Today we have K.R. Muralidhara, the Deputy Director of Sensor Systems area from ISRO. So he'll be talking on development of reliable embedded systems for space programs. So the brief introduction about today's speaker goes like this. We have K.R. Muralidhara obtained his BE in Computer Science and Engineering from SSIT Tumkur in 1993 and Masters in Computer Science and Engineering from Visvesvaraya University Visvesvaraya College of Engineering, Bangalore in 1997. He worked as lecturer from 1993 to 98 in the Department of Computer Science and Engineering in Adi Institute of Technology, Chikmagalur. He joined LEOS, ISRO, Indian Space Research Organization, as scientist engineer in the year 1998 in the Computer Science and Star Sensor Group. As a software developer, he has designed and developed embedded onboard software for various high accuracy sensors used in almost all ISRO missions since 1999. He has developed onboard software for different types of star sensors, star 3-axis and dual-axis fiber optics scopes, MEMS accelerometer package, and other embedded electronic systems. He's also developed fully automated software for functional testing and various subsystems of satellites and involved in establishing various test and characterization facilities. In his 25 years of service in ISRO, he has participated in more than 70 ISRO satellite launches and addressed many on-orbit observations through novel method called remote programs. His interests include algorithm development, software development, optimization techniques, processor architecture, data analysis, and remote program. He has to his credit several national and international papers. He has entrusted with the responsibility of Deputy Project Director for many missions and is the recipient of Team Awards of ISRO in the year 2007 for his meritorious service. Currently, he is heading Sensor System area as Deputy Director. Sir, it's our pleasure in having you on board today. I request you to please continue your presentation. Thank you.
Thank you, Mr. Raj, for your introduction. Anyway, that is introduction is a part and parcel of our life only. There is nothing special in that. So basically, I am a teacher. I worked as a lecturer, as Mr. Raj sir told, for 4.5 years in Adi Institute of Technology. The next migrated to Indian Space Research Organization. So I am representing today Indian Space Agency ISRO. So today, just we will discuss, as Mr. Raj told, in the next 20-25 minutes. So what is this embedded systems? Most probably these professors and whatever that professionals, I need not explain what is such embedded system. So we will directly go to that complex embedded system. Of course, nowadays these embedded systems are indispensable. We are using everywhere, starting from your household materials like refrigerators, your washing machines, even smart watches, and your gadgets. So many things are based on the embedded systems. But today our just a discussion is about how to design, develop, and deliver highly reliable embedded systems for complex systems like a rocket or a satellite or a tracking mechanism or a aircraft. So this is our agenda today. As you're seeing in the first slide, so Indian organization, space organization ISRO is an autonomous space body. So in that mean, we have the capability of building the launch vehicles like rockets, building the capability of the satellites, and tracking these satellites. That means all the three components are integrated, and in that way, we are autonomous space agencies. We are one among the 6 spacefaring nations. We are fully autonomous. So if you want to see the next slide, whatever I am showing is, today I wanted to just bridge the gap between the academia or the highly qualified professionals who are teaching embedded systems related subjects in the colleges and universities, and how we are going to realize that whatever the knowledge or theoretical informations we are having are a little bit of practical experiences in our lab to high-end reliable embedded systems. So this is the block diagram of our satellite. So a satellite is nothing but a system consisting of various subsystems. So a few names are like attitude sensors, actuators, propulsions, something like that. If somebody wanted to write a block diagram of a computer, simply write on CPU, memory, the input device, output device. Similarly, we are representing a spacecraft as a system consisting of many subsystems. Next slide, please. So if this, whatever block diagram, if we convert it into the physical entity, it looks like this. So of course, it is a one kind of a satellite. India is doing some 6 or 7 different kinds of satellites ranging from remote sensing, communication, and navigation, interplanetary. Of course, one more new vertical we are adding like a Gaganyaan and Bharatiya Antariksha Station. So of course, the size and structure of the spacecraft changes depending upon the requirement from mission to mission. But in general, the overall structure, it looked like this. On the body, what we call it the bus, we connected so many subsystems. So each subsystem is driven by an onboard computer, which is nothing but an embedded system. So next slide, please. So just to give a brief for this one, how it looks like. The subsystems are, after physical realization of our subsystems, they are look like this. We are going to integrate. Next. Yeah, again, these are all a few subsystems to give a glimpse of this one that the embedded systems. It is not only as, because why I am showing is a myth is there. Whenever we are calling the embedded system, people will assume it is only a software. It is not a software. A software on a platform called the hardware. So the next slide, next. Yeah. So these are all systems. Next. Yeah. Now, say for example, you go to previous madam. Say for example, you take one particular system. The system will look like this. It's a physical, so many physical entities are there. There is also some electronic circuitry. This physical circuitry, with the help of that electronic circuitry, whatever our program we are developing, that will be driven to give or perform the specific applications. So this is an exploded view of one subsystem. There are so many hundreds of such subsystems in the satellites. This is one exploded view. Go to the next one. Yeah, this is actually, so for example, if you take, first we on the paper, we will design like this. Whatever the previous slides I shown is the physical realization. So whatever now I am showing is a block diagram. So definitely this block diagram is written or taught in the universities or the colleges like this only. The lecturer or the professor job is to teach the students this block diagram. Now, once after that we are getting that experience, we are going to realize what in the previous slides, what I have shown. So now, how to bridge this gap between this black diagram to the physical realization. So now, we come to the embedded computing system. So that means to govern a body, an embedded system is actually, you are all aware of what is the definition of the embedded system. So it is a part of the electromechanical system, a computing system which is a part of the electromechanical system. So for example, a rocket is there. Rocket is weighing around some 1,200 to 1,300 tons. So in that, what is the size of the embedded computing system? It may be 50 to 100 kg. So like that, you take the ships, you take the aircraft. So everywhere this embedded system is there. Embedded system in the sense it is not a software or it is a physical entity. So it is a part of a computer system, which is an integral part of any larger system like the rocket, spacecraft, satellite, aircraft, and so many things. And these are all some general definitions. Already you have taught or you have already learned, so many papers are published what is meant by the embedded system or how it is characterized and all. But basic things what we have to remember in our mind is an embedded system consisting of 3 building blocks, that is a hardware, firmware, and the software. You leave the other physical entities. So for example, if you want to use the embedded system in the rocket, or if you want to design the embedded system for the rocket, I need not worry about the engines, the thrusters, and other things. All those large physical entities are connected with the first block called the hardware. That hardware may be your A to D converter, DTA converter, your multiplexer, or so many other things. Those things are now driven by a firmware. The firmware is nothing but a code which is implemented on FPGAs. So nowadays, you just leave it to the olden days embedded systems where within a one microcontroller or one microprocessor we use it to implement. But that is an era that is for a simple embedded systems. When we are talking about the rockets, spacecraft and other things, now we have to bring that FPGA. Whatever the code we have written for the FPGA is to interface the actual hardware. Hardware in the sense our electronics hardware. That hardware, of course, already due to connected through some transducers and sensors, it's connected to the other high-end mechanical systems or the electromechanical systems or the electro-optical systems. So in an embedded system, the first one is your hardware. The next, that is depending upon whichever the FPGAs you have selected, that will form the firmware. In addition to that firmware, that hardware and the firmware, once it is firmed up, then the software will come to picture. That is embedded software. But in all the three entities, everything is important, but the software or whatever the embedded software we are calling, that is more important because that will get or harness the power of that hardware and the firmware. So based on the whatever that firmware we are going to, that means FPGAs we are going to use, that modern embedded systems are classified into three or four categories. You just use a field programmable array, that is simple FPGA, or FPGA plus microcontrollers, or microprocessor, only microprocessor. Nowadays, actually, all the 3 years are over. Nowadays, we are using system on chip. It consisting of the microprocessor and FPGA. Whatever earlier that 2 kg, 3 kg, that big cards used to do, now one single FPGA and one single microprocessor and the microcontroller will perform. So now that means we are in embedded system, that hardware is there, firmware is there. Now we have to develop the software. Now software plays an important role. As I told, it will harness the power of the hardware, and also in any mission critical applications, it will play a very important role. Now actually, to design your whatever embedded systems, whatever low complexity and all, so you may not worry. Whatever we studied in our theory classes or whatever we conducted some experience in our lab, that knowledge is sufficient. But when we are going for a mission critical operations, that is not enough. That is mission critical always expect the reliability. That reliability factor may varies from 0.99 to 1. So that reliability is always representing between 0 to 1. So 0 means there is no reliability. 0.9 means 90% reliability. 1 means is 100% reliability. So for example, in our space missions, what we are looking for, reliability figure is some 0.96 to 97. That is 96% or 97%. But in a human space program, that reliability required is a 1. That is 100%. Then how to get this reliability? Whether reliability we have studied, whether reliability is through experience? No. For that only I have given, in earlier days, that software product is nothing but code plus documents. We return some codes and we generate some documents, what we call the manuals and other things. To the user, we are going to deliver the software plus documents. He is going to install using that manuals. He is going to get some information out of that. Again, that code plus document, some more advancement comes. Code plus data is also part of that program. That is a software product. Now, code plus data plus documents. So this is generally for other applications like online applications or batch applications. But truly for a real-time embedded system program, in addition to your code, data plus documents, we have to use some process, what we call the standards. Without these standards, we can't achieve 100% reliable for the complex system. For the low complex system, anyway, yes, we can achieve 99.99 we can achieve, and 100% we can achieve. So, for example, your smartwatch without these standards. But for a high-end, high-complex, reliable, real-time embedded system, to achieve reliability, we are supposed to use these standards. So then what is this standards? They are nothing but a set of whatever called the sequence or steps. So these are all something like other standards or other protocols used in the other industries like the telecommunication industries or network industries for software development also. So we have to use that. Then the question is, why we have to use these standards for only this software, embedded software? Why not we can't use for hardware or the firmware? Yes, there also we are using that standards. Every stage in the hardware development, every stage in the firmware development, we are using the set of standards. Using those set of standards only, we developed the system. Then what the standard says? The standard says it's something like a rule book. Then whatever the way you are going to implement the rule, that is left to you. They will not dictate in what way you are going to do, what to do only. Say, for example, your constitution tells there should be a law and order enforcement. It should be there in the society. So law and order, maybe it may be a police or military, or it is left to you. But there should be a mechanism to control the law and order. So in the similar way only that the standards defines the different ways, the different rules and regulations at each and every stage. So for example, you take the software lifecycle model, waterfall model, from specification, your design, your review, so many things are there, some 7 to 8 steps. In each and every step, what needs to be done? So once after all this, actually in these lifecycle models, the important thing is audits and reviews, what we call. 70 to 80% of our high-end complex embedded systems or embedded system, the cost goes for this audit and reviews only. There are periodic reviews, there are periodic audits, what we call the code walkthrough. So for example, if I develop the 1,000 lines of code, the 1,000 lines of code not directly go to your flash memory as an embedded software. It will go to series or sequence of, that means what I call the audits. In each and every audit, the professionals or the experts in that field are involved. They will verify whether code is okay or not okay. It contains any, these are all things. So that means now actually in industry, so many standards are available. Starting from IEC, that is ISO 12207. It started in the 1950s by the US Department of Defense. That is what we call the MIL standard. That military standard is always defined by the either NASA or the military department of US. So now these standards actually they implemented, they had some success. So now again all other space agencies or other embedded systems try to adopt these standards. But of course, now 12207 is not there. 12207 is periodically upgraded. Every year or every 6 months, these standards are upgrading. So now actually what we are using 12207, ISO 12207 with the tailor-made. What is this tailor-made? Actually, this NASA or military standard will define the standards. But that standards may not completely applicable to you. They will give an options to exercise. You can tailor-made it. You can tailor it. That means you can add your own. You need not subtract it. You can add it. Some other standards. Yes, ISRO or DRDO that requires some other standards. Just we can add it. But why we are selecting the 12207 as a software lifecycle standard? Because of the flexibility. Lot of flexibility is there. If you select some other, say for example 1903 or some other standards, they will strictly tell this is the life cycle model to be adopted, this is the tools to be used, and so many other things. But 12207 will not put any such constraints on the developer. The developer is free to select any life cycle models. The developer is free to select any tools what you wanted. But what the 12207 says is, right from the specification, design, coding, code walkthrough, implementations on the FPGA or implementation of your flash memory, the next delivery, maintenance, in each and every stage, there is a clear-cut definitions it makes. So that's why that almost all, not only I think ISRO, even DRDO and other agencies are also adopted this 12207. Of course, ISRO, what we call the ISPD 12207, that is ISRO Software Process Document. We are calling a document. It's something like a Bible for us. So we are developing almost 6 to 7 different categories of embedded softwares. For launch vehicle, one kind of software is there. For onboard, checkout, mission, image processing, scientific. So many varieties of software we are developing. Of course, for the embedded software category, it is only 2, either what we are using for the rockets and the satellites. But the standards we are using for all categories. So now what I want to convey to that audience is, we have the potential or capability to do the programs. We can develop the programs. There may be people who can develop 1,000 lines of program a day or 2,000 lines of a program a day. But only the reliability is important. How to make these 2,000 lines of codes as a reliable software product? Unless otherwise, if you are not using this standard, it is very difficult. Then what is the, actually, I am telling the rules. What the standard will tell? The standard will tell different tools to be used at a different stage, starting from specifications. You want to abstract the specifications or to clearly mention the specifications, lot of tools are available, even in the MATLAB, AROHAN. So many people are now, they are ready to give the tools, even for the specification extraction or making the specifications for your system. Next, design guidelines, coding guidelines. Even coding, say for example, in our laboratory, what we will do, we will define one statement and we will select one programming language and we will do. Once when problem is when defined itself, we have to choose that programming languages carefully. either C, C++, ADA or Pascal. So many languages are available. But what's the fundamental duty of the embedded software developer? The beginning itself is to properly select the programming languages. Loader should be available, test cases should be available, so many things should be available. So that means now in an embedded systems, actually what we are preferring is either use C, C++ or go for ADA, because industry has lot of the tools for these languages. Compilers are available, assemblers are available, debuggers are available. You need not worry about so many things. So many system programs are available for the selected language. So for selected compilers. So like that. The next slide, man. So now, what we did actually now, say for example, basically we joined as a simple engineers, what we learned in our colleges. So now with that experience, using this standards, using this tools, so now today we are developing the design, development, delivered so many embedded systems for our launch vehicles and the spacecraft. So what I wanted to convey is using these standards only help us to land on the moon on the August 23rd of 2023. That soft landing is due to the standards. Because once the system is made, the complete control is taken by your software, that is embedded software. The flawless operations of this embedded software makes 100% soft landing on the south pole of the moon because of the standards what we are following. So again, the next slide, what we are going, it's not only our achievement. We are going to have the reusable launch vehicles. It is also an achievement in future. And also we are going for the docking missions. So where 2 or 3 spacecrafts we are docking to get some information or for repairing or to extend the extended life. Actually, that is once that end of life is completed, the ISRO is trying to extend the life of the other spacecraft. End of life, so for example, 5 years or 10 years, the defined life. So we are, by enhancing our capability of the embedded software, so we are extending the life. How it is possible? There is a technique called the remote programming. That means on 600 kilometers or 36,000 kilometers when spacecraft is there, using our communication antennas, we are programming there. Already a program is sitting in the spacecraft. We wanted to modify it. Yes, we can modify it. How it is possible? Because we are using that standards. Of course, it is entirely left to the person. Without the people knowledge, there is no substitute for the human intelligence. But when the human intelligence is mixed or combined with these standards, it is nothing but putting a ice on the cake. So in that way, a successful embedded software developer, not only that the knowledge, whatever he is possessing is not sufficient, you should also follow, he should also follow some rules and regulations, whatever defined by these standards. So then only we can achieve that reliable figure of 1. Of course, we achieved 0.99, what you call 99% in our previous missions like Chandrayaan 3, when we are going for the manned missions. So definitely the required reliability figure is 1. We are going to achieve with these standards. So with that, I most probably, so just it is a discussion actually. What I am trying to say is whatever you people are doing in the classrooms and the laboratories, still it is adequate to develop the embedded software, but a little bit gap is there. That gap you can fill with using these standards. So these standards are nothing but a good practices used in our day-to-day life of the software development. So with this, just I wanted to conclude, and thanks a lot for all your patience hearing. Thank you, sir.
So thank you very much, sir. If there are any questions from audience, we'll take up quick 1 or 2 questions. Please raise your hand virtually. Yeah, it looks like I think.
Okay, thank you, sir. Thank you. We'll meet again. Thank you.
Yeah. One second, sir. Just on behalf of our DT officials and all the participant audience, I wholeheartedly thank you for this valuable time, spending valuable time and sharing your views on embedded systems. And it's a great experience for all of us to know how and hands-on that what are the difficulties, the challenges we face when you try to work with satellites. And really, we are honored today to have you on the board of our lecture series. So thank you very much, sir, once again, and for your spending your valuable time. So
Okay, thank you, sir. Thank you.
thank you. Okay, so now we have the next presentation by Dr. Raviraj from Government Engineering College, Chamarajanagar. And today is he'll be talking on training and placement. One second. We'll be talking on training and placement, campus placements, the potentials in government engineering colleges in Karnataka. And regarding the brief introduction about him, he did this bachelor's degree in mechanical engineering from UBDT College of Engineering, Davangere, and MTech from material engineering from NTK Surathkal, and PhD from VTU Belagavi. And has also worked as a research associate at IISc Bangalore. So, Dr. Raviraj, it's a great pleasure to have you on this particular lecture series. Now, I request you to please take over the session.
Okay, thank you, Basra sir. I hope I'm audible.
Yeah, you are audible.
Yeah, I'll just share my slides.
Yeah, please.
Yeah, okay. Good evening, everybody. Respected Principal Secretary, Higher Education, Government of Karnataka, respected Commissioner, Collegiate and Technical Education, respected Director, Department of Technical Education, Professor Basra sir, and my dear colleague friends who are present online here. I welcome all of you to this lecture series 4 of AROHAN 2024. Which is a very fine initiative taken by our Higher Education Department along with Professor Basra sir. So I would like to talk about training and campus placements, particularly in GECs, and I would like to speak about the potential in GECs. So because I was working previously I was working as a training and placement officer, so I thought this would be the best topic to discuss among my colleagues, so that in future GCs will have very good training and campus placements records. So today we'll be discussing about, we'll just discuss about the evolution of training and campus placements. I'll just talk about history about campus placements, training and campus placements in GCs Chamarajanagar. And what I thought is we'll do the SWOT analysis, because in GCs we are still in the budding stage to grow to a very higher level of academics. So I thought I would do the SWOT analysis of this campus training and campus placements. And finally, I would like to say a few factors which can help to bring the companies to our colleges, and we can have better campus placements for our students. So basically, campus placements, it started in the early 1990s, particularly with software companies like Infosys and Wipro and all. But training concept was not in that stage. But in 2013, Ministry of Corporate Affairs, Government of India, it had recorded an enactment of Companies Act, and it initiated this what is called as CSR initiatives. So CSR is basically corporate social responsibility initiatives to be taken by the companies, particularly who are hiring engineers and other qualified people. So basically, the CSR initiative is taken by these corporate companies, and this enactment of Companies Act, what it did is it imposed statutory obligation on companies towards social welfare activities. So basically, CSR is it combines people and business ecosystem and environment So with that, this training concept came into picture in 2013. After that, campus placements. So this basically CSR it's a practice which is taken over by these business operations companies, and where they integrate social and environmental goals into the business operations for better profitability of the companies, and also for better advantages of the social life of the people. So basically, basic roles of CSR we have. Basically, it is for controlling the costs of the company, and also improve the company's brand, and facilitate long-term financial successes. Along with that, one more important role of CSR is attracting the top quality talent, particularly in the campuses. So that is where this training concept came into picture. And along with this training, campus placements, they both flourished. And now we're in a stage where the students, before they join your college, they will ask, what is your campus placement records? So that is where I think GC should be in forehand, and they should improve and take this campus placements and training seriously, so that the name and fame of GCs will rise to sky high. So before going to the further details, I would like to talk about my college, GEC Chamarajanagar, because for last 6 to 7 years, I was a training and placement officer. So I got a very good experience and knowledge about campus placements, and also about training, which was initiated by these companies through CSR. So basically, it was the first company was TCS. All of you know that. So whatever I'm talking about GC Chamarajanagar, it will be same to all other GCs, because all these companies, what you see here, they all have approached government engineering colleges, and they started giving this training, and they helped in campus placements. So basically, the first company who approached our colleges, GC, particular GC Chamarajanagar, was TCS, and with them we initiated MOUs. And next one was Wipro. Then we have series of companies, Technologics, IBM, Birla Groups, Keynes India, Global Quest, like that. So the blue color companies, they are actually giving training, and also as well as the campus placements for our students. And we have some other institutes like Q Spaders, DTRI, HJC Mysore, Edunet Foundation Bangalore. So they actually they are like finishing schools, finishing colleges, which give training after the graduates graduation, and they help in placements. So that's why I have marked them in the red color. And we have some just like CSR, even GC Chamarajanagar, we also have some social responsibilities, and we give some services to some institutes like Nirmiti Kendra in local Chamarajanagar, and we have Youth for Seva, so where our students will go and serve the society. And also we have given some training to government PU colleges for boys in Chamarajanagar. So with this, I would like to say that Chamarajanagar is in the middle, where we accept training and campus placements from the companies, and also we are undergoing the CSR responsibilities, and we also serve the society with our knowledge and experience and people. And I would just like to give some records, data of the campus placements done over the last 4 to 5 years. And you can see the companies here on the left hand side. We have TCS, basically because they started the training, and also they started the campus placements in our college. So TCS was very important for us, and it made a large amount of impact on campus placements, in particularly, I think, all the GCs. So we have Wipro, then Keynes, like that. We have many companies here. So you can see here that students' interest, it was fluctuating. So what we expected was the training, it was